Hello guys, welcome back to my channel Ping and Play. Today I'll tell you what is OSPF. It's a dynamic routing protocol. Before going to OSPF, let's tell you one thing. In my previous class, we have discussed about static routing. So we saw how the router finds the best path to a network. We configured the static routes manually and traffic was able to flow from one router to another router. See here, R1, R3. If R1 need to communicate with R3, this R3 route will be in R1 routing table. We need to add that route manually. Correct? Route. Manually, we need to add that route into R1 routing table so that only R1 can communicate with R3. R1 communicate with R3. That is the static routing. In my previous video, I have explained clearly. Please go through it. So the disadvantage of static routing is first we know the destination address. Sorry, this one. Destination address and the subnet mask and next hop. We need to add these things if you want to enable the communication between the routers by using static routing. Correct? What should we have? What if we have thousands of routers in our organization to maintain that network? Is that a possible to add every route into every routing table? Is that really reliable? No, it's not. In that case, OSPF comes into the picture. It will add the routes because we can't configure a static route for big network. Hence, we use dynamic routing protocols. See here, routing protocols will be there. Routing protocols divided into static and dynamic. Static I have completed. So in dynamic routing protocols, again it will divide it into distance vector, link state protocol, both distance and link state protocol, and path vector protocol. So these protocols called IBGP. These protocol called IG internal gateway routing protocol. Internal gateway routing protocol. This path vector protocol is external gateway routing protocol. That is called BGP. I'll explain in further videos. Don't worry. So internal gateway routing protocol means it enables the communication with within yes within AS. AS is nothing but administrative distance. So that is so this IG internal gateway routing protocols will enable the communication between within the autonomous system within the autonomous systems. If we enable the communication between different autonomous systems, we need BGP. Sorry, that is external gateway routing protocol. BGP will enable the communication between different autonomous systems. So autonomous system is nothing but internet having the collection of autonomous systems, guys. Okay, internet is a collection of different autonomous systems. Clear? So we'll discuss about OSPF. So here I have written the basic overview. It's a open shortest path first, and OSPF is a dynamic routing protocol used in IP networks to determine the best path for data packets. It is a link state protocol. Link state protocol is nothing but every OSPF router will maintain the link state database, so that it called link state protocol. And now each router in OSPF domain will maintain the network topology. As I said, it is an interior gateway routing protocol designed for large and complex networks. So it is flexible per subnetting, and OSPF choose the best path on the lower cumulative cost. Cost is nothing but it's a metric. So based on this cost, it will choose the best path to reach the destination for packets, data packets. It uses multiple multicast IP address 224.0.0.5 and 6. I'll tell you. It is a current version. I think V3 will be there. Is used for IPv4 networks, while OSPF V3 is used for IPv6. Yeah, okay, yes. OSPF version 2 is used for IPv4, version 3 is used for IPv6. It is a version, guys. Okay, so don't confuse. Okay, right now, and these are the commands, and this is the OSPF header. I'll show you the packet flow as well. Okay, don't worry. So these are the OSPF. These are OSPF states, guys. These are OSPF states. While forming the neighborship between the routers of OSPF, it will goes several states. Several states in the sense it will go through 7 states when forming a neighbor relationship. Down state, initialization state, two-way state, extract state, exchange state, loading state, full state. Okay. Downstate is it is the initial stage of OSPF. No OSPF communication. When we configure the here, see here, when we configure the OSPF configuration here, it will start sending the hello packets through 224.0.0.5 multicast group IP address. If the parameters will be matched, the same thing will do by R2. R2 as well will send the hello packet through 224.0.0.5. If the parameters will be matched, this R1 and R2 form the OSPF neighbor relationship. This R1 and R2 will form the neighbor relationship. So in the init state, router has received a hello packet. In that hello packet, in the initial state, the router can see the own router ID in his neighbor packet. In two-way state, bidirectional communication will be done. In the extract state, the exact database description packet will be exchanged. And in the exchange state, routers exchange the DVD packets. In the loading state, routers request missing LSA details. LSA details is nothing but if see here, if R2 is connected connected to R3, here R1 R5 router will be connected to R1. So these LSAs will be sent by R1 to R2. This R3 details, R2 will get the LSA and give it to R1, exchanging the link state request. Next, loading state, routers request missing LSA details. Full, complete neighbors adjacency and convergence achieved. Now we'll go to this is the basic overview of OSPF. In my next video, I'll explain in detail these states in details. Now I'll show you the configuration. See here, in the down state, initial stage of OSPF. Initial stage of OSPF and we listen the IP address first. Config T interface G1/0 IP address 10.0.0.1 255.0.0.0 no shut interface loop 1 IP address 1.1.1.1 255.255.255.255 do show IP interface brief. See here 10.0.0.1 up and 1.1.1.1 loopback IP and then second config terminal interface G1/0 IP address 10.0.0.2 255.0.0.0 no shit int loopback 1 IP address 2.2.2.2 255.255.255.255 do show IP interface brief. See here okay now we'll do the packet flow as well. Okay okay router OSPF here this is the process ID. Every area should have process ID. Okay here I am giving the process ID 10. All we need is to advertise the routes network 1.1.1.1 wildcard mask 0.0.0.0 area 0 okay network 10.0.0.0 0.255.255.255 area 0. So I'm giving the command OSPF now. Here you can see it will start sending the hello packet through multicast IP address. See here 224.0.0.5. I'm open the packet capture in the OSPF header. I have seen here version message type hello packet packet length source OSPF router checksum authentication type authentication data. These hello packet See here, network mask, hello interval, options, router priority, router dead interval, designated router, backup designated router. Okay, in the options, we have many things. Okay, these parameters should be matched. Then only it will go to second stage. See here, every 10 seconds it will sending the hello packet. Okay, after configuring the OSPF, it will start sending the hello packet through multicast IP to 224.0.0.5. Okay guys, clear? If the parameters will be matched, it will go to init state. In the init state, from the neighbor hello packet, it will see its own router ID. What is this router ID? 1.1.1.1. In the neighbor hello packet, it will see its own router ID. R2 will see its own router ID in R1 hello packet, like 2.2.2.2, so that bidirectional communication will be done. So the state down state will be done. In the initial state, it will see the own router ID in hello packet, and two-way state bidirectional communication will be done. In the two-way state, bidirectional communication will be done. Bidirectional communication will be done here. In the extract state, it will start exchanging the routes, database descriptions. Okay. Next, R2 exit router OSPF 10 network 2.2.2.2 0.0.0.0 area 0 network 10.0.0.0 0.0.0.0.255.255.255 wildcard mask, right? Area 0. See the packet flow clearly here. Okay, see here అన్ని స్టేట్లు వెళ్ళిపోయినాయి, right? DB description, hello packet, and link state request, link state update, link state acknowledgement, everything. So this is how we'll do the OSPF configuration. In my next video, I'll explain in detail about OSPF states. Okay, I have given the basic overview what is OSPF, but my primary thing was to showcase the configuration of OSPF in this video. Okay, so this is how OSPF, see here, OSPF adjacency will be done. You can see here, do show IP OSPF neighbor. See, the state will be full. Do show IP OSPF summary. OSPF router ID is 2.2.2.2, process ID 10. Sorry. So that is all about OSPF. In my next video, I'll tell you about. I'll explain these states clearly. The states I will explain clearly, and there is topics will be there, that is OSPF states I will explain in my next videos. OSPF areas, types of LSAs, OSPF multi-area lab troubleshooting as well. I'll explain these things in my future videos. Please do the labs, guys. Then only you can come to know what was the packet flow while forming the neighbor relationships. It will very useful for to complete the labs. Okay, guys. Bye bye. Thank you for watching this video. Please like, share, subscribe to my channel, ping and play. Please do support, guys. It will take milliseconds to you to subscribe my channel.